10.2 is a problem that we worked out partially in class. It says that a motorcycle moves with an initial velocity of 30 meters per second. That's velocity right here, so we can put 30 meters per second right there. And it says that brakes are applied and it decelerates at a constant rate. So we can put a horizontal line right there. This is a little different than what we did in class. I'm just going to put a minus 5 meters per second squared over to the side. That'll be okay as long as we realize that our acceleration axis is inverted from normal. So negative values are actually on top of the horizontal axis in this case. Since it decelerates, the trend has to be for velocity that you slow down until you reach 0. Okay, and then the next question is, what does the x look like as a function of time? Now I know that the equation of this line right here is given by our kinematics equation. The velocity is dependent upon time. It starts off with some y-intercept right there, and the reason it's going down is because acceleration is negative 5 meters per second squared. Now to get this one, you can assume that you start at the origin, but you cannot assume that this is equal to 0, because it's not. It's equal to 30 meters per second times time plus 1/2 times negative 5 meters per second squared times t squared. So this is the addition of two different functions, and what that means is that you have a function that's a straight line that's going up like that, and you're subtracting off of that a function that is curving down. Let's see if maybe we can try it another way. If you curve it like this and you say it's this function minus that one, it's a little bit hard to see, but if you were to use Excel, I'm just going to tell you what the trend is going to look like. You can use Excel to plot this out, and you'd find out that it would be over arcing like that. A little bit hard to figure that one out. For the acceleration, it's constant, negative 5 meters per second squared. And for velocity at 2 seconds, you plug in the acceleration right here. You plug in the velocity right there. That's the initial velocity. And you put in the time right there. And that allows you to find velocity. To find the x position, use 30 meters per second times 2 seconds plus 1/2, negative 5, 2 seconds squared, and that goes right there. Make sure you put a number with units in both of those spots.